Okay, so sensitivity analysis. We want to do some analysis based on your output. You already run the Excel and you get the output decision. Okay, so we want to do some analysis. How sensitive is your output? Okay, all right. So we go first to. Okay, so briefly explanation about the sensitivity analysis. Okay. All right, we want to see if there is a changes in input parameters, so would affect the optimal solution or not? When you run the Excel, the solver in the Excel, okay, and you get the output, you get the solution, okay, to produce how many golf bag, deluxe bag, standard bags, kan? Product A, product B, how many gallons for product A and product B, like example previously, okay. So that is your optimal solution. Okay, if there is a changes in the input parameters, means that there is a changes in the selling cost per unit. Okay, changes increase in cost per unit. Would your optimal solution change or not? Okay, so how it will affect your optimal solution? Okay, if there is let's say there is a changes in the availability of your resources. Okay, then how this will affect your solution. Okay, all right. So in sensitivity analysis, this is in analysis we will answer this. I mean that the major question here, two major question. Okay, so if there is a change, like I said, changes in the objective function. Okay, cost per unit or profit per unit, will it change your optimal solution? Or change in the right hand side, change here the availability of your resources, change the minimum requirement, would it affect the optimal solution or not? That is a major answer lah. Okay, right, the main answer question to answer, right? Okay, so we go to example minimization problem. Okay, so we go to the example for minimization problem. Okay, this is like in the previous class. Okay, we already run it and get the optimal solution. Okay, so this is a sensitivity analysis. Okay, how you get this table? Okay, so this is an example. Last class we run at MND. Okay, example problem for MND and get the solution to produce product A 250 gallons and product B 100 gallons. Remember that when you run the answer and I ask you to click to get these three reports. Okay, answer report, sensitivity report, and limits report. Okay, so that table is from the sensitivity report here. Okay, you get this sensitivity report here. Okay, so I copy this table, I put it in the slide, so it's easy for me to explain for you. Okay, so this is a table from the Excel here. Okay, sensitivity and sensitivity report. Okay. Okay, so from this table, you can see what the first column here for the first table, variable cells here. Okay, the first table, the first column is your solution. Okay, product A 250 gallons and product B 100 gallons. So this is your solution, final value. Okay, this is a reduced cost. Okay, so how much to reduce the cost so that you can produce this product. Okay, normally if you have the figure here, if there is a solution, the solution to produce all product, then you will get the reduced cost 0. Okay, let's say when you run the solver and only solver only suggests to produce product A 350 example, okay, right? 350 product A. So product B will be 0, okay, because the minimum requirement is 350, is 0 here. Let's say, okay, this is it. So there will be figures in the reduced cost here. Okay, so reduced cost is a if there is a final value in this column, second column will be, you will have a 0. Okay, so if any row in first column is 0, then you will have some figure in the reduced cost. To suggest the reduced cost to suggest you how much cost that you have to reduce so that you can produce this product. Okay, so only that you get 0 here, then you will have some figure here. Okay, so normally if you have a final value or in all your products, so you have 0 reduced cost. Okay, so this is how much cost to reduce so that you can produce that product. Okay, all right. Objective coefficient. Okay, so this is a cost per unit. Okay, so objective coefficient, cost per unit. Okay, so allowable increase, allowable decrease is give you how much you can increase or increase or reduce the objective coefficient here so that you can maintain the solution here. Okay, this is your optimal solution. If you want to maintain the solution, 250 and 100, 250 and 100. Okay, sorry, I forgot to inform you that sensitivity in analysis, there's no calculation. Okay, so only you to interpret figures in this table. Okay, all right, so just interpretation. All right, so allowable increase, let's say you want, let's say the cost increase from $2 to $3. Okay, it's still it's an allowable value. Okay, so that you still can maintain this combination. Okay, you can still continue to produce product A 250 gallons and 100 for product B. Okay. Okay, so this is infinity. Okay, IE plus 30, this is for infinity. Okay, infinity. Excel cannot generate alphabetical in the report. Okay. Okay, okay, so this is the range 2. Okay, so it can increase it to, sorry, not increase. It can reduce to any value, no limit, okay, to reduce cost for product A. Okay, but for product B, you can increase to any value. Okay, this is infinity, but you can reduce only $1 from $3 to $2 only. Okay, by $1, so that you can maintain. This is to maintain the final value here. Okay, I think there's a okay. So this is for first column. Okay, so second column, first column, sorry, first table. Okay, so first table, second table, final value. The final value here is the final, the final constraint that you use or you produce. Okay, all right. So product A, provided product A minimum is 125. Minimum, this is constraint right hand side. So this is the requirement here. Requirement is 125. Minimum requirement 125. But actually you produce 250. Okay. Total production minimum is 350 and you produce 350. Processing time available is 600 and you use all 600 hours. Okay. All right. So shadow price. This is a shadow price. Okay. Let me explain a little bit about shadow price. Okay, so shadow price for a change in the optimal objective function. If you increase the right hand side, you increase 1 unit. Okay, you increase here 1 unit here. ni, right hand side ni, you increase right hand side, this is the effect to your total cost. So in this case, cost lah, okay, total cost. Increase 1 unit minimum total production requirement 350 to 355. So total cost will increase $4. Okay, total cost. Increase 600. Okay, this is the effect by increase 1 unit here, effect to your total cost. Okay, your objective. Okay. Alright, so for non-binding constraint, okay, non-binding will have a shadow price 0. Okay, non-binding means that you produce less than what available, or you produce you use all to the more than minimum requirement. Okay, so either you have a slack or surplus. Okay, the shadow price will be 0. Okay, shadow price is, you will have a shadow price only for a binding constraint. Okay, binding constraint, because you use all the requirement or you produce at the minimum, so that's small restrict lah. So will affect some objective, affect your function, your objective. Okay, alright. Okay, so the negative shadow price. Okay, negative shadow price means that objective function, change in objective function for a decrease of 1 in right hand side. Okay. Okay, this is a reduced cost. I already explained reduced cost. Okay, it's for that's for your objective function, your objective parameter. Okay, all right. Okay, so in this report, say, I will explain here to achieve constraint. Okay, and then the allowable increase and allowable, this one, okay, on top here is for objective coefficient. Okay, this is for right hand side constraint. Okay, so range for right hand side. Okay, sorry. Okay, so requirement product A, okay, allowed to increase from 125 minimum requirement tu, that means yes, you produce 250, but the minimum requirement, okay, now minimum requirement 125. Right, so you can increase the minimum requirement, you can increase another 125 gallons. Okay, means that up to 250, you can increase either 200 up to 250. You can increase that minimum requirement to 200 or 225, but up to 250 only. Okay, that is the maximum amount. Okay, and you can reduce any numbers. Okay, means that up to 0 lah. Right, so you can reduce to any numbers. The minimum requirement here, you reduce this figure, not final value. Okay, all right, so you can reduce right hand side any constraint for minimum requirement for product A is another 125. Okay, but in between that you can 100 or 50, any value lah within maximum to 125. Okay, so processing time. Okay, you have a negative shadow price. Okay, processing time increase. You are allowed to increase 100 hours. Means that from 600 availability, you can increase up to 700 hours. Okay, and can reduce up to it can reduce by 125 hours. Means that up to 470 hours only. So the range here is up to 470 hours to 700 hours. Okay, right, so you can increase the availability of processing time. Okay, this is indicates a change in the optimal objective. This one, okay, any changes in the right hand side, this is the change in your objective. Okay, this two is a binding constraint. Then binding constraint have a shadow price. Non-binding constraint, no shadow price. Okay, so interpretation here, $1. Okay, how to interpret this $1? If a processing time increase 50 hours, means that now the availability is 600. Okay, so you increase 600 to 650. Okay, so you increase 600 to 650, so that we can say that the objective function total cost will change by -1 here, shadow price time by 50 because you increase 50. So -50. So that total cost will be 750. Okay, so you increase 50 hours, 600 to 650. Total cost is 800. If you refer to the Excel, its total cost is 600. So your total cost will reduce by 50 because you increase 50 hours. Kalau if 100, then minus 100 hours lah. Okay, so now is the example use 50. So $50. So the new total cost is 750. Okay, so if the processing time decrease, you reduce from 600 to 600 to 550. Remember the range here is you can increase up to 100 and you can reduce about 125. Okay, right? So let's say if you decrease processing time by 50 hours. Okay, so that objective function total cost will change by -1 times by 50 because 50 hours -50. So total cost 800 minus -50. So the new total cost you reduce processing times. Don't ask me the reason why. Okay, so this is the maybe they have another Excel read. They have an compared to another constraint. Okay, can see not really mean that you reduce the total hours, but maybe have there's another impact. Okay, all right. So but based on this figure, that's why when you make a decision, not only based on your intuition or your experience, you can support by figures. But when you get the figures, you have to support by another type of decision too. Okay, all right. So cost that, but this is only based on the figures lah. Okay, so this is for this cost based on the figures only. But in the real situation, you cannot totally based on the figures. Okay, all right. So you reduce the 50 hours, so the total cost will increase to 850. Okay, so that is for shadow price for processing time. Okay, so this is the shadow price for minimum requirement for both product A and product B. Okay, so let's say now you increase, remember this is allowed to increase 125 and allowed to decrease 50. Let's say you increase 100 gallons, the minimum requirement. Okay, minimum requirement 250 plus 100, so you increase minimum requirement 350 to 450. So that objective function will change by $4 here. Shadow price $4 times by 100. The change here will change by 400. Okay, so that the total cost will be 800. Total cost is 800 plus 400. So total cost will be 1,200 if you increase your minimum total production. Okay. Let's say if you decrease by 40, cannot reduce 100 because it allowed to decrease only up to 50. You can reach 50, but in this example, we use only 40. Okay, decrease 40 gallons, 350 minus 40, so reduce to 310. So the objective function here 4 times 4, the shadow price is 4 times by 40 gallons ni. So we change by $160 so that the total cost will be, because it's a decrease, so you have to minus 800 minus 160. So new total cost would be 640. Okay, right. So that's how you interpret the shadow price, and it must be compared with the range here. Let's say if the question asks you, okay, let's say if you want to change, you want to increase, the manager want to increase. Okay, so let's say the manager want to increase the minimum requirement for total production 350 to 500. Okay, 350 to 500 means that you will increase 150 gallons. Okay, you increase 150 to the minimum requirement to increase. You want to increase up to 500. Can you do analysis? Cannot. Okay, you cannot times by 4. Okay, because the 4 value here, you can use this $4 ni, $4 shadow price up to 125. If the changes is out of this range, means that you cannot do analysis. Okay, based from this figure, you have to rerun the Excel. Okay, you cannot based on. So let's say if you want to reduce the minimum total production from 350 to 250, can you do some analysis? This is only for analysis. Okay, can you do analysis? Cannot, because the numbers that reduce is more than allowable. So you have to run a solver again based on the new figures. Okay, shadow price is you can apply this. The shadow price is only applicable for this range only. Okay, within this range only. Okay, right. If you want to see the changes is more than this range, then you have to run the solver again. Okay. Okay, so this is as long as the cost product A is between infinity and then equal to 3. Okay, so you can maintain the current solution. Okay, so if you increase from $2 to $2.50, then you don't need to resolve the model. Okay, right? Same as Ivan already explained to you. Okay, so as long as within this range, you don't have to resolve the model. Okay, you can just continue your combination product mix. Okay. Okay, but however, the assumption, the range here, assumption here, that only one piece of input has changed. Means that if you change the, if there is a changes in the coefficient, in the objective coefficient for product A only, then you can use this table. Okay, if there is a changes in both function, both coefficient, product A and product B, both change, then you have to one piece. Okay, okay, if two or more, if there is a changes more than two, okay, what you should do, you have to rerun the solver. Okay, rerun the solver. Manually, you can calculate based on 100% lah, but in this textbook ni, it suggests you to rerun the model if more than two or more changes. Okay, that all the whatever it is ni, the interpretation ni is based on one piece changes only. Okay, one piece input. Okay. Okay, sorry. Okay, this is for bag. Okay, for bag here. Okay, their final value. This is for golf bag. Golf bag. This is the sensitivity report for golf bag. And then I will explain later. Final value here for this for output, and then this for the constraint, the actual constraint. Okay, shadow price here, and the range here, and also the range for coefficient and range for right hand side. Okay, all right. So this is the optimal solution. standard batch 540 and 250. So this is how you interpret. Okay. Right. So the actual constraint, this is the actual constraint is 150 hours, 100. Okay. So this is how you interpret. Alright, so 4.375 interpret here if the cutting and dyeing, okay, this is for the first constraint, cutting and dyeing department, increase, okay, increase 52.36 hours, okay, allowable is allowed to increase, okay, 630, you are allowed to increase about 52.36 maximum lah, okay. So let's say the department increase 52.36 hours from 630 to 682 hours. Okay, so the objective function will change by 4.375 ni shadow price times by the number of hours increase. So, okay, so you get 229. So that total profit will be, this is the original profit, 7,668. Okay, so this is plus 229. So the new total profit, if you increase the cutting and dyeing department hours, your profit will increase by 7,897. Okay, so the manager have to decide lah whether you want to increase or not. Okay. If the cutting and dyeing department decrease, okay, to the maximum lah, allowable decrease ni, this is the maximum, okay, it decrease 134 hours, okay, up to 495.6 hours. Okay, so the objective function we change by the shadow price times by the number of the hours that decrease. So the new total profit is total profit 766,000 minus 558. Okay, so the new total profit is 7,080. Okay, minus times here. Right. Okay, so this is number 4. As long as the profit for deluxe bag is greater than or equal to 667 here, range, okay, so 9 minus 2.33 and 9 plus 5.286, okay, so the current solution here remain optimal. You can continue to produce this combination, okay. Right, so finishing hours, you are allowed to increase within this range only. Okay, right. Okay. Yeah. Okay, sorry, I forgot to change to reset for this question. Okay.
Doctor, I want to ask.
What?
Doctor.
Huh? What?
Doctor, I want to reconfirm, doctor, for the last exercise. The answer is minimize total cost by 1,250, right?
What? Sorry, I cannot hear you.
The last exercise, doctor.
Last exercise.
The answer is minimize total cost by 1,250, isn't it?
The last exercise. Which one? This one?
No, doctor, the exercise, the quiz that you gave to us.
Let me see. Oh, this one. Is it this one?
Yes, doctor.
Okay, so your question is number of soccer ball and
No, the minimized total cost is 1,250, isn't it?
yes.
Okay, thank you, doctor.
Okay. Okay. Actually, for this one, I focus more for this exercise here. It's not quiz, okay? So this is a exercise, okay? For this exercise, actually, I forgot to delete this question, okay? So I focus more on how you develop a linear programming. I give you a simple question just to see whether you understand or not to develop a linear programming, okay? So that's why I focus, when I explain to you, I focus more on how you develop the linear programming. Can you see my slide? You can see my slide, isn't it?
Yes, doctor.
Okay. So in this question, I focus more on linear programming because I mean that the objective for this course is not to avoid you to solve using an equation, okay? Because linear programming in the real actual situation is not as simple like this, okay? It's more complicated. Okay, that's why I didn't discuss at all about the simple equation. Okay, so we use a linear programming. So focus more on how you develop the model, not based on the solution. Okay, all right. Okay, don't worry about your ni, as long as you understand to uh, uh, how to develop the mathematical statement from this statement. You transfer to the mathematical statement. So then should be no problem to get the correct answer based from the Excel. Okay, this is just a simple, give you simple problem. So that's why you can solve using an equation. But in the actual situation, it's not only based, it's not as simple as this. You have so many resources. You have, this is for your high school, okay, simple mathematics, then you can solve using an equation, okay, right? Okay, so another simple question, okay, for you to see whether you understand it. Still using a class point. Okay, so select, choose option A or B. If 100 or more hours available for cutting and dyeing department, total profit will increase. Okay, is it true or false? Eh? Is it already closing? Okay, no more submission. I will close the submission. Sorry. Anyone would like to submit? You just press A or B, should be no problem. Okay. So I assume only 8 students would like to submit. Okay, okay. Okay. Okay, so I will close the submission now. Okay, so if 100 more hours available for cutting and dyeing, okay, total profit will increase. So you go to the cutting and dyeing here. Cutting and dyeing, the range is more. Allowed to increase is 52, allowed to decrease 134. Okay, right? So the question asks you increase 100, isn't it? So 100 is more than allowable increase. Okay, allowable increase ni more than dia punya allowances ni up to 52 hours, 52.36 hours only. Okay, all right. So 100 more hours available means that 100 is more than 52. Like I said, more than allowable value means that you don't know what happened to your total profit. That only will affect the total profit within that the shadow price. So you can see the shadow price that will increase the total profit as long as it's within the allowable value. Okay, so 100 more hours is more than allowable value. So it's actually we don't know whether it will increase or not increase. You have to rerun the model. So the answer is false. Okay, so congratulations for those who answer false. Okay, right, you have a correct answer. Okay, sorry, I have to reset. Why is it? Huh? Why is it cannot save here? Sorry, sorry. There's some problem here. Oh, okay. All right. Okay, suppose spa company still in this same problem, like to increase the inspection and packaging to 200 hours. Okay, so the objective or total profit will increase. Is it true or false? Okay, no more submission. I will close the submission. Did you try to understand the question or you just follow the other? Can see 100% answer true. Okay. All right. So no more submission. Then I will close the submission. Okay. You can no longer submit. Okay. So suppose Spa company would like to increase inspection and packaging to 200 hours. Okay. So you make conclusion the objective function total profit will increase. It will increase. Okay, another 200 hours. So you go to the sensitivity analysis to see inspection and packaging. Okay, so inspection and packaging hours used, you are allowed to increase infinity and allowed to decrease only 18 hours. Okay, shadow price is 0. So if you increase 200, shadow price is 0, and then you times by 0. Yes, you can increase infinity, but any value times by 0, is there any changes in the total profit or not? Okay, refer to the inspection and packaging here. And the shadow price is 0. Okay, the changes is 200. And you can increase infinity. This is an infinity value. You can increase up to any value. Is there any changes in the total profit? You times by 0. So how much total profit will increase? 0. So it should be no changes in total profit lah. So the answer should be false. Okay. All right. So remember that any changes here, as long as within the range, okay. As long as within the range, then you have to times by shadow price. Okay, so if for inspection and packaging, shadow price is 0. So 0 means that there is no changes in the profit. Even though you increase 700 ke 500 ke, still no changes. Why? Because this is a non-binding constraint. Okay, they still have additional hours. So why you want to increase? Even though the availability, but you use not all the maximum hours. So what for you want to increase another hours, isn't it? Okay. So available 135, but you use only 117 hours only. Okay. So no point for you to increase additional requirement. Okay. From 135, you want to add another 200 hours. No use lah. Will not impact to any profit. You will not use that. Okay. Yeah.
Doctor.
Yes.
So to make it easier, so whenever the number like it will be the increase like 200, and then it is in the range of the allowable increase, then we just need to times it with the shadow price, right?
Yes. Yes.
And if it is not in the range, then it's definitely will be false, or there is no increase.
You don't know whether there is the increase or you don't know how it will change your objective function. Okay, if there is a out of range, means that you don't know how it will affect your objective function. So if the statement say increase, then it's false lah. Okay, even though if the statement say decrease, also false, because you don't know what will happen to how it impact to the objective function. Okay. First you check the range. Okay, so if within the range, then you times by shadow price. Okay. So if by how much, then you can get the value. Okay, if they don't ask you by how much, then just put the statement that it will increase lah. Okay. Okay, I want to do one exercise together with you to help you to understand more about this sensitivity analysis. Okay, to see the question and example how to do this analysis. Okay, so you can take a break 5 minutes for me to get ready with the question. Okay, all right. I will share the in Telegram, okay, the document. So if you want to print or you want to write on that document, you can do it. Okay, but if you want to go to toilet, whatever, you can have a 5-minute break. Okay. Afla, what password that you need? You didn't get the password. What password? Which password?
For attendance.
Attendance.
For attendance, yeah, for attendance.
Oh, for attendance. 5555555. Okay, so this is the example, first example. If you have time, then we can do both example. Okay. All right. So Anastasia operates a small business. Okay. So she produced seasonal ceramic object to sell to a tourist. For the spring, she is planning to make a basket, eggs, and rabbits. So these three product. Baskets, eggs, and rabbits. Based on your discussion with your aunt, you construct the following table. So this is the requirement, okay, for this problem. Okay, product, basket, eggs, and rabbits. Okay, all right. So this is the resources, the requirement, the constraint here, mix more requirement, clean, okay, paint and seal, hours, in hours, and this is the profit per unit, okay, for product. And this is a capacity for each maximum capacity for each resources, okay, or each process, right? Okay, and then this capacity here, in this case, I don't ask you to create a linear programming, okay, because I want to focus only to the sensitivity report, okay. Another additional requirement is that your aunt also has committed to make a 25 rabbits for charitable organization. Okay, it's already committed, so means that rabbits must produce more than 25. Okay, so sensitivity report here, 3 product, basket, eggs, and rabbit. So the value here is number of your solution lah. So in this solution, suggest to you to produce 25 baskets and 25 rabbits only. 0 eggs. Okay, see 0 value here, then you will have some figures in the reduced cost. Okay, right, means that if you want to produce egg, you have to reduce cost for eggs by $1. Okay, original value here 2.5 for basket. Okay, cost profit here, okay, profit per products, and this is the range here. Okay, a constraint, we have 4 constraint, requirement of resources, and also the minimum demand for rabbits. Okay, 25, because already promised to the charitable organization. Okay, so this is the actual constraint that you use. Okay, mix or more. You can see that 0 shadow price for mix or more. Okay, clean, because still this is a non-binding, you have additional 1.25, okay, pound for mix more. Okay, clean, you use all, you have available 50, and then you use all 50. Okay, so that's why there is a shadow price. Okay, remember shadow price, binding constraint, no shadow price, non-binding, shadow price. Okay, but only this one you have a negative shadow price. Okay, so now this is the example of question for sensitivity analysis. Okay, so what is the solution to the problem and which constraint are binding? Okay. Okay, so the solution to produce 25, okay, based from this one, 25 basket and 25 rabbits. So this is a solution, 25 basket and 25 rabbits only. Okay, and which one is the binding constraint? Oh, sorry. And then your total profit here. Can calculate total profit. Okay. 25 times 2.5 plus 25 times 2. Okay, so you can calculate total profit. Okay, so you get the total profit. That is your solution. Okay, so which constraint are binding? Which constraint are binding from this one? Which constraint are binding? Hello. From these four, which constraint are binding? Okay. How you determine which constraint are binding? First, you can compare your original value, okay, the availability of your constraint, and with the actual constraint that you use, or refer to the shadow price. Okay, shadow price only have figure shadow price for binding constraint. So, which constraint are binding?
Current and demand.
Thank you. In and demand. Okay, so constraint, binding constraint, keen and demand, because it has shadow price, and if you compare with the availability and the actual that you use, the same value. Okay, which additional resources would you recommend that Anastasia to try to obtain? Okay, so because these resources, you have to refer to these three. Would you to recommend the availability of mix more, or keen, or paint and seal? Which one? This one you should refer to additional. So you want to suggest to Anastasia to have more for that resources. Okay. So this one you should compare with the effect to the profit. So in this case, in this three, you can see if there is a changes in mix or more, okay, increase in 1 unit for mix more, no impact to any to your total profit, no changes in your total profit. Okay. Additional 1 unit for keen will increase $2.5 for keen. Total profit. Okay. Increase 1 unit for paint and seal hours. Okay. So no changes in the total profit. So which resources that, yeah, thank you. Okay. So you should suggest to increase keen. Okay. Because it will increase 1 unit. You increase keen. 1 unit increase, 1 unit keen you increase, then you can it will increase $2.5. Okay. All right. Suppose the charitable organization contact Anastasia and told her that remember they promised to 25 rabbits kan? So they underestimate the number rabbits that they need. Okay. Instead of 25 rabbits, they need 35. How would this affect Anastasia profit? Okay. From 25, it will increase another 10 lah. Okay. So compared to allowable increase, allowable okay, increase lah. Okay, so allowed to increase 25, but it's only increased 10. So it within the range. So within the range, then you can calculate the impact to your total profit. So how will this impact profit? With increase or decrease? Increase or decrease? Increase or decrease to the Anastasia profit. From 25 here, you increase to 35, will increase or decrease the total profit? Negative, impact negative, increase or decrease total profit? Increase 1 unit will decrease profit by 0.5. Okay. So increase or decrease?
Decrease, doctor.
Decrease because it's a negative. Okay, so will decrease. Profit will decrease. Okay, because why? Because it's a negative. Yeah, okay. From 25, if you change, you increase, will decrease the profit. If you reduce the figures, then will increase the profit. Okay, so the negative relationship. Okay, profit will decrease by how much? By negative 0.5 times by 10. How much? $5. $5 kan? Okay, will decrease by $5. Okay, so anesthesia available hours for pain and seal have fallen from 80 hours to 60. Okay, so this one from 80 to 60. So decrease about 20 hours because of other commitments. How will this affect her profit? This one, apa tadi? Pain and seal here. Okay. Is it allowed to decrease 55, but now you only reduce 20 units, so within the range. Okay, so you can do some calculation. So reduce 20 hours. So how would it affect to the total profit? Is there any changes? Pain and seal here, is there any changes? You reduce 20 hours.
No, doctor.
Why?
Because it is in the range,
Range
and also the shadow price is 0.
yes, thank you. Because it's a shadow price 0. Okay, even though there is the changes within the range, but it will not impact your total profit. Okay, it will not change. Okay, so Anastasia is planning for next spring. And she is considering making only 2 products. Now 3 kan. Okay, based on the result from the linear program output, which 2 products would you recommend that she makes? Now currently she makes 3. Okay, but based to optimum the profit, it suggests to produce basket and rabbits. Now she want to focus only 2. So which products would you suggest for Anastasia to produce? Which one? From these 3, you want to focus only 2.
Basket and rabbits, doctor.
Basket and rabbits. Okay, good. Because 0, because based on the output, it suggests to you not to produce eggs in it. So based on that output, you produce basket, it suggests basket and rabbits. Okay. Okay, so Anastasia, last one, Anastasia feels that her prices are too low, particularly for her eggs. Okay, so a price too low. How much would her profit have to increase on the eggs before it is profitable for her to make and sell eggs for eggs? Okay, that's why, because too low. Okay, that's why it's suggest not to produce. Okay, so now the original value is 1.5. It asks you to reduce by $1, reduce cost. Okay, this is a profit and this is to reduce cost. Okay, the question asks you how much would her profit have to increase on the eggs before it's profitable. How much? Okay, so reduce cost by $1 means that profit will increase about $1 lah. Okay, $1 lah. It should increase profit by $1. Assume that you reduce profit by $1, so you will get more. You reduce cost. You reduce cost, okay, not reduce profit, even though your coefficient in profit, but still that is for cost. Okay, reduce cost by $1. Okay, automatically we assume that your profit will increase by $1. Right? Okay, so increase profit by $1, then there is a possibility that for her to make and sell eggs. Okay, all right. So should increase profit to increase by $1. That is the minimum lah. Okay, all right. But however, okay, sometimes $1 is a border. Okay, so this is the border minimum. Okay, so there is a possibility. Where's the okay? So here. Okay, so $1 is the possibility, is a border. So when you increase by $1, the actual figures, you will have an alternative solution. Same solution here, you can maintain this one, or you can have a different, and total profit will be same. Okay, you have alternative decision. Okay, all right. So either you can maintain here, or there is another another solution. Okay, if you increase by $1. Okay, so that is the minimum profit that you can increase. Okay, reduce cost $1, then you can increase profit by $1. Okay, right? Any question?
So the one is minimum, right?
That is a
Uh,
minimum. Okay, so you
like
can write minimum increase by $1. Okay, you should increase minimum by $1. Can increase more. Okay, too confident to make sure that increase more. To make sure is, let's say if I want to make sure that it will profitable and want to produce and sell that eggs, means that she should increase more than $1, at least 1.1 or 1.5 ke kan, more than $1. That is the minimum increase. Okay. All right. Okay, so this is another second question. Okay, so I think that the second question you can try to understand and do try to do this. So next class, in next class, then we can discuss about this. To see whether you understand or not about this sensitive analysis. Okay, right? Okay, any question? If no more question, then I think that's all for today.
I have one other question. Where can I find the recordings?
Recording, okay, and next time I will share the recording in the Putra Blast. Okay.
Okay, because I would also need the recording from the chapter 2 because I missed it since my registration wasn't finished, and I tried to solve the exercise you did, but I couldn't.
Oh,
So I wanted
okay.
to check the recording.
All right. I will. I can't remember whether I record or not during our first for chapter 2. I can't really remember. But however, I have a recording for the previous class during last semester. The same thing. Okay, I use the same example. But if I don't have a recording for this semester, I will share with you the previous one. Okay, all right.
Thank you so much.
Okay. Thank you for reminding me. Okay, so I will try to share by this by today lah. Okay, so probably by tonight I will share all the recording. Okay, all right. So one more thing before we end the class, for your second test. For your first assessment. Okay, so first test will cover for chapter 1 to 3 lah. So minimum a few questions only for chapter 1. So let me see. Almost here. Non-Muslim sini, majority lah, okay, majority here non-Muslim, so you won't celebrate you won't celebrate anything next week, isn't it? Okay, so do you prefer to do the exam, because this is a take-home exam, okay? I will give you a question and then you have to submit within 2 days, okay? And I ask you based on your preference, okay? Do you want to do next week, okay, week 6, or Because even though you do next week, I will check by next week, by the other week, okay, after break. Next week, then we have a term break, okay, 1 week, and we have another week to complete, okay. Test one should, first assessment should do between week 5 to week 7, okay. So do you want to do first test before your semester break, or you want to do it after semester break, after Hari Raya lah, after Idul Fitri? Probably maybe I give you on Tuesday until Thursday. You have to submit by Thursday. So based on your preference.
Right now, like it's hard for us, like for like fasting and Eid and everything. So for me, I think it's better like after the break.
After the break, okay? How
Like
about
for me,
others?
like maybe they can say before, no problem. I have no problem, but still, like I prefer
Yeah,
like
I know, I
after.
understand. Yeah, I know, I know the situation because it's fasting. I mean that it's quite hectic, isn't it? So how about others? Is it okay if you do it? We do the first assessment after the term break. To be honest with you, even though you do it next week, you do the assessment next week, I cannot check your test next week. Okay, I will check again by the week after term break. Okay, so same for me, no problem. Even though you want to do after term break. How about others? Is it okay? Probably maybe I give you on Tuesday and you have to submit on Thursday, 2 days. Normally I give you 48 hours to complete the question.
I also prefer
Prefer what? Prefer
after break.
after break, okay? Okay, so can we get agreement that your first test is after term break, which is let me see the date. The term break is start from 30 April until 8 May. Okay, so your term break, your test one, I will assign start from Tuesday 10 of May until 12. Okay, so the first week after semester break. Okay, right? Agree, eh?
Okay, Doctor.
Guna Selvi on you before. Okay, I think can we refer to the majority or not? Okay. Okay, thank you very much. All right. Okay, so that's all for today. Inshallah, I will share to all the recording every chapter in the Putra Blast tonight. Okay. All right. So have a nice day. Don't forget to key in your attendance. Okay. Bye bye. See you next week.
All right, thank you.